Okay, welcome back. This is part 3 to a series of videos on spreadsheets being used in the context of minimum perimeter and maximum area of rectangular enclosures. The one thing I did not mention and I think would be helpful is not a mathematical one, but in terms of preparing this information for assessment, if I'm not able to be around to view your computer screen, it would be essential that you either uh, email a copy of that to me um, or print a copy of that off. So if you had to prepare a report in which you needed to justify, that is to provide proof of your reasoning or of your answer, then I would probably print a copy of these dimensions or of this spreadsheet. In order to do that, what you'll want to do is highlight the area that you'd like to print. Okay, let's just say it's that. We'd go to page layout, and under page layout you'll see print area. So I'm going to select that and I'm going to set the print area. Now upon doing that, you're going to notice this particular outline here is surrounding the printed area. So as long as everything you want printed lies within inside this enclosure, then it's going to print. Okay? Now, for instance, what would happen if it lied outside of it? Let's just give consideration to if you also needed to print off and show your formulas. You can see now that the printable area is going to stop here at this dashed line, and this particular column lies outside of it. In order to bring that column back in to the printable area, we're going to resize the columns. Okay, so now you can see, just a moment here, there, that this now lies within inside this enclosure, and we'll know it's going to print. Another way to check that out too is once you've set the print areas to go back to the home page and then select to print. And when you do go to print, you'll see a preview of that, and notice that all of the column headings are there, all of the data is there. Okay. Another thing you can do as well, I'm going to go back to the home page, and I'm also going to go to the view, sorry, back to page layout for a moment, and when printing the grid lines, we can also choose to print those, and I'll show you what that looks like. It's actually a benefit or a bonus for the reader. That way it makes it easier to read the printout. Okay, so just a couple of tips when it comes to printing. All right, so we're done with that particular problem. I'm going to close that file off. I don't need to say the changes to that as it's an instructional file. And we're going to move into, or at least have you move into this problem, which is the practice problem regarding minimum perimeter with a fixed area. Okay, so we'll read the problem statement together, and then I'm going to have you pause the video and then give it a try. See if you can take it far enough to answer both parts A and B to the problem. The extension problems will be done in a later video. Okay, if you'd like to challenge your thinking just a little bit more with regards to these concepts and the use of spreadsheets in exploring these concepts. Okay, so let's set up the spreadsheet. This time I'm going to leave out the rectangle number. It may not be entirely necessary, unless you're going to refer the reader to a particular row, but we can do that just as easily without having a column labeled as rectangle. So we'll have width, then we'll have length, it's all in meters, followed by perimeter, and then area in squared meters. Okay, if you don't like the look of the column, if it's blocking out information, you can always resize it as such. And for our width, what we'll do is we can start with 1 unit, and then we can then increase that by 1 unit. So I'm going to add 1 to cell A4. Oops. Let's change that. There we go. And we'll copy and drag that down. As for the length, remember that the length is the area divided by the width. Okay, because the area of a rectangle is length times width. And by rearranging the formula, length is the area divided by the width. Well, currently I haven't specified the area in the spreadsheet, so I should do that. So let's go over here and enter 24. And then over here, I'm going to set that as a constant. So that's going to be cell D4. And divide that by cell A4. And there we have it. We'll copy and drag that all the way through. Oops. Just verify. Yes, 24 divided by 2 is 12, divided by 3 is 8, so the formulas are working well. And cell D4, as you can see up here, is remaining constant in our calculation. The perimeter, if we look at the problem, it is a four-sided enclosure. Okay, so remember that when we started the unit, a four-sided enclosure has a perimeter that is twice the width plus twice the length. Okay, or we also looked at the formula as being perimeter equals 2 times the width plus the length. Okay, so either formula will work. Let's use the second one just to make things a little bit different. So we're going to have 2 times the width, okay, which is cell A4. And to that we're going to add cell B4, close bracket, and I got a correction. Notice that the asterisk needs to be used for multiplication, so let's accept that change. And we'll verify mentally that 2 24s is 48, plus 2 ones is 2, that's 50, so that's correct. So let's copy and fill down that formula, and then we will create a column that has our perimeters. So in tracing this downwards, you can see that our minimum perimeter occurs when the dimensions are 5 by 4.8, and we get a minimum perimeter of 19.6. Currently that's fine, but it does beg the question, based on earlier work with a four-sided enclosure, the square produced the minimum perimeter. Here we don't have a square, yet we're awfully close. So in the next video, let's see if we can't manipulate this spreadsheet to show us that particular information.